This is the Kenyan teacher. We present the expected responses to questions from the topic Organic Chemistry as tested in the year 2022 KCSE Chemistry Paper 2. Welcome. In the year 2022 Chemistry Paper 2, Organic Chemistry was tested as question number 2. Organic chemistry is one of the topics that is rarely missed in Chemistry Paper 2. Actually, every other year we expect a question from this topic. Question number 2. The general formula of alkanols is CnH2n plus 1 OH. We are then told in part A to draw the structure and give the name of the alkanol with N is 5. So if we replace N here with 5, we shall have a formula of C5H11OH. So drawing the structure here would not be a difficult task, as candidate was expected to just draw 5 carbons in a straight chain, of course bonded by single covalent bonds. Then we expect now the hydrogens to fall in place as indicated here. These would be 11 hydrogens in total, and then our OH group would come on the terminal carbon. Remember, if you're told to draw the structure, even O and H here should fully be open. That was worth 1 mark. We are then told to name whatever we've just drawn, and the name here would be pentan 1-ol, to mean that the OH group is attached to carbon number 1 for the next mark. However, a candidate who didn't show the position of OH group by just giving us the name pentanol also deserved the mark. Now, when it comes to the structure here, we would accept any other isomer of C5H11OH. For example, if a student drew the structure of 2-methyl butan 1-ol and any other isomer that a candidate would think of, then we would still give the mark. So we would accept the straight chain alkanol with 5 carbons and any other branched isomer of the same. To part B, we are told table 2 gives the boiling points of some alkanols. So we have N being 2, boiling point 78.5 degrees Celsius, N being 3, 97.2 degrees Celsius, N being 4, 117 degrees Celsius. We were then expected to draw a graph of boiling points of these alkanols against the number of carbon atoms in their structure, represented by letter N. So let us go ahead and do exactly that on the grid that was provided. So we are asked to draw the graph of boiling points of our 3 alkanols given in the table against the number of carbon atoms represented by N. Of course, the grid was provided here, but we need to remind ourselves that when N is 2, the boiling point was 78.5. When N was 3, the boiling point was 97.2 from the table, and when N was 4, the boiling point was given as 117.0 degrees Celsius. So let us now go ahead and draw our graph. For purposes of saving on time, I had earlier drawn the axis. So what we shall do next is just choose an appropriate scale. So for us to score the mark on scale, there is this one rule that we borrow from maths, which states that the plotted points must cover more than half of the total area of the grid given. So if we look at our x-axis here, we were given a total of 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and 14 squares. To score the mark on scale along the x-axis, we are actually demanded that we use either 7 or more squares. Our plotted points must cover 7 or more squares on the x-axis. For that matter, the most suitable scale that we shall use is 4 squares to represent one carbon atom along the x-axis. So I would start with the least number given in the table, which is a 2 at the origin, and then I move to 3 after 4 squares, 4 after another 4 squares, and I end with 5 after another 4 squares. When I do these, I will have utilized the squares on the x-axis more appropriately to score the mark on scale. Now, for the y-axis, we are again given 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 squares. So again, to score the mark on scale, we are demanded to use at least 7 of these given squares for us to score the mark on scale. So the best a candidate to do would be to start at 75 degrees Celsius at the origin. Then we would use a scale of 1 small square to represent 1 degree Celsius. So from 75, I would move to 85 after 10 small squares, then 95, then 105, then 115, then 125, and I would end at 135. From here, I would now plot my points. So when n is 2, I'm told the boiling point is 78.5. So here is 75, 76 after 1 small square. Sorry, 76 is here after 1 small square, 77, 78, and then 0.5 would be the middle of this other small square right there. When n is 3, I have 97.2. So here is 95, 96, 97.2 is just small length, very short length after 97. That is where my plot would be. And when n is 4, I'm told I have 117. So this is 115, 116, and 117 would be 2 small squares after 115. Once I'm through with plotting, I would take a straight edge and join my points. So here we are. I've done the plotting. I now join my points. using a straight edge. There we go. That would be my curve. So it is 3 marks. I would score scale a half for x-axis and a half for y-axis, giving me a total of 1 mark. And we've agreed that for you to score, the plotted points must cover more than half of the area of the grid given. Next mark would be for plotting, and here I will have 1 mark if I plot all the 3 points correct. I would score a half by plotting 2 points correctly, and I would get 0 if only 1 point is plotted correctly. Finally, the third mark for my graph would come from the straight line that we've just drawn using a straight edge. That gives a total of 3 marks. Now, the first question after drawing the graph is asking us that from the graph, we are supposed to determine the boiling point of an alkanol with N is 5. This 5 was not covered in the table, but at least as we were drawing our graph, we catered for 5 here. So what a candidate was supposed to do was to extrapolate your graph. You are supposed to extrapolate your graph till you reach a situation or a section where the number of carbons are 5. So we would do this using dotted lines. And once we do that, we would then read the value of the boiling point. And of course, you have to show evidence that you have read your graph. So right here, where we have N being 5, you'd tell us that you have actually used your graph to draw, or rather to read the value of the boiling point. So if we do so, here we are showing evidence that we are actually using our graph. So if we did this, we can actually see that when N is 5, the boiling point is 136 degrees Celsius. So that would be the answer to our question down here, 136 degrees Celsius. But remember, we have to see evidence that we have used our graph. Let us proceed with the next question, still on number 2. This is part B, question 2, part B, Roman 3, and we are told the boiling point of the alkanol with N is 2 is much higher than that of butane. Remember, butane is an alkane, but here we are dealing with an alkanol, so we are told to explain. And the answer here would be quite easy. An alkanol with N is 2 is actually called ethanol. So this alkanol ethanol has hydrogen. It has hydrogen bonding between its molecules. This we know that alkanols are actually polar, just like water, while butane, which is an alkane, only has van der Waals forces, which are weak van der Waals forces between its molecules. This would be the difference in the boiling point. So it's 2 marks. Ethanol having hydrogen bonding, 1 mark, and butane having weak van der Waals forces, another mark, giving us the 2 marks. We now proceed to part C of question 2. Part C, Roman 1. Alkanols are used as fuel. We are asked to give another use of alkanol. So here we have quite a number. Alkanols can be used as solvents. We can also use alkanols as disinfectants. We can also use alkanols as antiseptics. Alkanols can also be used in alcoholic drinks or beverages. We can also use alkanols to make synthetic fibers. And again, we can use alkanols in the manufacture of other derivatives of organic compounds. In this category, derivatives of organic compounds, we have things like alkenes. We can use alkanols to manufacture alkenes and even alkanoic acids. Any of those would be worth 1 mark as dictated by question 2, part C, Roman 1. In Roman 2, part C, we are asked to write an equation for the combustion of an alkanol with N is 2. So we have CH3, CH2OH, that is our ethanol. Of course, you can make this even more simple by writing C2H5OH. Reacting with oxygen during combustion to give carbon dioxide and steam or water. Of course, we balance with a 3 on oxygen, a 2 on carbon dioxide, and another 3 on steam or water for 1 mark. When it comes to organic compounds, reactions involving them, we do not insist on state symbols. So a candidate would afford not to write them, just as we have done. Let's move to the last question. We are asked to use the bond energies in table 3 to calculate the enthalpy change that accompanies this reaction that we've just written the equation for. So we have bond, carbon-carbon single bond, 348 kilojoules, carbon-hydrogen, 412, carbon-oxygen, 360, oxygen-hydrogen, 463, oxygen double bond, oxygen, 496, and carbon-oxygen double bond, 743. So for us to be able to answer this question correctly, we need to open up all the bonds that are there in our equation here. So for ethanol, we would have CH3, so that we're able to know which bonds we shall break. Then CH2, here we are, then OH. Reacting with 3 of oxygen double bond oxygen, that is here, to give 2 carbon 4 oxide is having that kind of bonding, and we have 3 of water. So when you open them up like this, we are able to see all the bonds that should be broken and those that should be formed. So let's begin with bond breaking energies. Bond breaking energies. So here, for this reaction to take place, we need to break all these bonds in ethanol and all these bonds in oxygen. Let's begin with ethanol. For ethanol, I have 5 CH bonds. 1, 2, 3, 4, 5. We have 5 CH bonds. And before we continue, bond breaking energies are actually endothermic, and our signs are supposed to be positive in the calculations to show that bond breaking is an endothermic process. So let's now go ahead. We've agreed that CH bonds are 5. So we shall multiply 5 by 412. According to our table, CH bond is accompanied by 412 kilojoules of energy. Here we are. Then, apart from the 5 CH bonds, we have one CC bond. So we shall add 348 kilojoules to our value because we are also breaking one CC bond. Then we have CO bond. According to our table, CO is accompanied by 360 kilojoules. And finally, we have an OH bond here that will be accompanied by 463 kilojoules. With that, we are through with our ethanol. So we go to oxygen, and for oxygen, we have 3 that we shall multiply by O double bond O, which is 496. Adding all this, we should now get the total bond breaking energies. 5 by 412 is supposed to give me 2060. I'll add to 348. I'll add to 360. I'll add to 463. And I'll add that to 3 times 496 is supposed to give me 1488. So the total bond breaking energy comes to positive 4,719 kilojoules. I now proceed now to the product side where I get bond formation energies. And before I do the workings, I need to take note that bond formation is an exothermic process, and therefore my sign would be negative. Now, I have CO bonds. I have 2 times 2. That would be 4. So 4 CO. CO is accompanied by 743 kilojoules of energy. This I'll add to OH are 2 here times 3. That would be 6. 6 into HO is 463. So when I do the sum, I'm getting 2972 for 4 times 743 added to 2778 for 6 times 463. Now this gives me a total of negative 5750 kilojoules for my bond formation energies. And to get now my enthalpy change, I need to add bond formation energies to the bond breaking energies. When I do this, I get a value of negative 1031. This time my units are kilojoules per mole. So this working is 3 marks. I'll be awarded half a mark for getting the total bond breaking energies, another half for doing the correct addition. I'll get half a mark for the correct additions for bond formation energies, a half for the total bond formation energies, a half for the addition, and a half for the final answer. That gives a total of 3 marks for that section. And with that, we've come to the end of our review of question 2, chemistry paper 2 for the year 2022, where organic chemistry was tested for a total of 13 marks.